All right, we're going to now look at lesson 9.5, congruence transformations. So, in central understanding, you can use composition of rigid motions to understand congruence. So let's take a look here at this. So the composition, which is a reflection across line N of the rotation of 90 degrees around point P of figure LMNO, is equal to GHJK, shown to the right. So the question says, which angle pairs have equal measures? So how do we know which ones match up with what? So what we're going to do is we're going to take, and we're going to start with this figure here. So we're going to rotate this figure around point P, which means if you rotate 90 degrees, it's going to form a right angle. So that means this is going to be point O. We'll go in red here so we can see a little bit better. So this is point O. That means as we rotate this figure around, this becomes point L. As we rotate this figure around, this becomes point M. And then this becomes point N. So this is going to be O prime, L prime, M prime, and N prime. So we use the prime, just remember to show that these points become this. So now we're going to reflect it across here to become this here. So which ones match up is the question. Well, if we were to reflect this over here, that means the closest points are going to match up. They're across from each other. So the ones, what you could do is, if you looked at perpendicular lines, you could see exactly if it was skewed. So we can draw a line here, across here, perpendicular. These would be perpendicular. And as you can see here, these are what the lines would look like as you draw them across. So that tells us here that, and so when it asks us which ones measure up from our original figure, okay, so if I say O prime, that's going to be the same thing as O, and it's going to be congruent to the one across from it, which is going to be angle K. And then we do L. Okay, so L is going to be congruent to, if we look across here, it's going to be G, angle G. And then we're just working our way around here. We have M. M is over here, M prime, so that's going to be congruent to H. And the last one here would be our N. And N is going to be congruent to J. So O is with K, last and last. L is with G, first and first. M is with H, and N is with J. So one thing you can notice here is that each of these will match up in the same order like we've always done in congruent figures. So this congruency statement can let us also figure out, without even having to look at the picture, what is going to match up with what. So in this case here, if we look at all of our line segments, we know that LM is going to be congruent to GH. And then we look at M and N, it's going to match up with H and J. And then we have N to O is going to match up with J and K. And the last one here is going to be L and O matching up with, and over here it's going to be G and K. So the picture here is to kind of show you how this works, but remember we can always look at our congruency statement in order to figure out what things match up. So let's take a look at the second part. Which ones are going to match up? It's going to be a reflection or rotation, a reflection of cross line T of the translation of 2, 3 of triangle ABC to map onto triangle XYZ. So list all the pair of congruent angles and congruent sides. So let's do this together. Angle A is going to match up with angle X. Angle B, it's going to match up with angle Y. And then angle C should match up with angle Z. And then if we do the segments here, the sides of our triangles, we have the segment AB going to be congruent to XY. Then we have BC. That's going to match up with YZ. And then we have the last two, first and last, A to C is congruent to X and Z. All right, so let's take a look here at some definitions. So in example 1, you saw compositions of rigid motions preserve corresponding side lengths and angle measures. These are all rigid motions. This suggests that this is another way to define congruence. Two figures are congruent if and only if there is a sequence of one or more rigid motions that maps one figure onto another. Because compositions of rigid motions take the figures to congruent figures, they are also called congruence transformations. So another name for rigid motions is going to be congruence transformations. Which pair of figures in the grid are congruent? For each pair, what is the sequence of rigid motions that map one to the other? So it depends on how you select these, is how you identify it, because it could be going in the reverse direction. So let's say we start with triangle EDF, person over here. Okay, so we're going to see which one it matches up to, and it's going to match up to this over here. So one way to look at this is if we notice we could draw a straight line from F to N. If we drew a line from D to L and E to M, they would form a straight line, which means this is going to be a rotation. So we could say this is a rotation of 180 degrees around the origin of triangle EDF. And it's going to equal the triangle over here. So we got to match up the right part. So E goes with M, so that's going to be M. And then we do it to the right angle here, D, so that's going to be the right angle L. And then the last one be N, MLN. Okay, so let's try the next. Let's take a look at figure PQ. Let's take this line segment here. So how do we get it from here to here? Is it a translation? Is it a reflection? Is it a rotation? So let's see here. The slope here is up 1 over 1, 2, 3. So this right here is up 1 over 1, 2, 3. So this looks like it could be a translation. So we're going to slide it from here to here, which means that we're going to write down a translation. And the rule would be if I go from P to H, that's going to be over 2 to the right. And then I'm going to go down from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be a negative 9 because I went down. So we have the translation of 2, negative 9. The figure is going to be line PQ. And our result will be line HG. So let's look at our last figure. We have our trapezoid here. So this one looks like it's not necessarily going to be a reflection or a rotation. It's going to end up being a composition of transformations. So let's look to see what it could be. So let's see, we could slide this up here. This could be a glide reflection. We could slide it up here and then reflect it over a line. So easiest way to do this, since they're 1 unit away, is going to be to move it to this line here. So we're going to move it one place to the right. So this is going to be a composition. We're going to do a reflection across the y-axis. It'll be a capital R. Y-axis of the translation, and we're going to go 1 to the right, and then we're going to have to bring this, how many up? Well, that's going to be 1 to the right and go up 1, 2, 3, 4, and 5. So 5 up. That's our Y figure. Now we're going to say figure, this will be figure A, B, C, and J. And our result is going to be W, X, Y, and Z. A goes with W, B goes with X, C goes with Y, and J goes with Z. So these are just 3 examples. Now if you went from this to this, of course it'd be just the opposite. We move it 1 to the left, move it down 5, and we reflect it over the line, that would be x equals -1. So it all depends on the direction you move it, in which figure you move first. All right, so example 3, identifying congruence, transformations. In the diagram at the right, triangle JQV is congruent to triangle EWT. What is a congruent transformation that maps triangle JQV onto EWT? So we're going to start with J, Q, and V, and we're going to map it onto this. So as we look here, we want to see, could it be a translation? Could it be a glide reflection? And that's what it does appear to be, which means I could move this up and then reflect it over. Now because the distance between these is 2, that means the line halfway between would be, once again, the y-axis. If it was an odd number, you'd want to move it right over to either somewhere where you can flip it easily, where it's an even distance between the two, or you can move it right to this dot and flip it over that. So there's really a lot of different choices you could do here. But let's pick and let's try sliding it up. So we're going to slide it up here, and then we're going to reflect it over. So this will be as we write this down, you always write the second move first. So this is a reflection across the y-axis of a translation. So let's figure our translation. We're going to move this Q onto the one it maps to, which is going to be Q and W match up. So I'm going to move this up 1, 2, 3, 4, and 5. So I'm going to move it 5 up. So that's going to be a Y value. And I'm not going to move anywhere on the X. So I'll say 0 and a positive 5. Now this becomes of my triangle JQV, and we're going to equal EWT. This is my translation. So move it up here, which puts this point here. That's Q. The J would move up here 5 units. 1, 2, 3, 4, and 5. It'll be J prime. And V is going to move up here 5 units to be V prime. So this triangle looks like this. And then as reflected over here, it's going to map perfectly. So Q and W is going to match up, J and E are going to match up, and V and T. So you always have to pay close attention to make sure you match up which parts go together. All right, so for part B, I want you to figure out which congruence transformation that maps triangle NAV to triangle BCY. So pause the video and then come back and check to see how you did. All right, so let's take a look here. We're matched up. I picked V and Y. I knew that they matched up. So I can move V over here 5 units to the left to right here, and then we can reflect it across the x-axis because the distance between here is even, so that means that this line would be in the middle. So it's a reflection across the x-axis. The translation, I'd move this 5 units to the left and up and down 0 of triangle NAV to equal triangle BCY. So once again, always make sure to see which parts match up. I knew that B is going to match up with N, and C is going to match up with A. So in order to do this and flip it over correctly here, it would have to be sliding this way and then flipped over this axis. All right, this concludes lesson 9.5, Congruence Transformations.